Hello guys, welcome to Self-Help Maths Academy. In today's discussion, we will start with the properties of matrix transposition. So here, the transpose of the matrix, if I have, then the transpose of transpose will be equal to the given matrix itself. And then transpose of the sum. If A plus B transpose I have, that is nothing but A transpose plus B transpose. Then transpose of the scalar multiplication. If I have a C as a scalar, C A transpose is nothing but C into A transpose, where C is any scalar. So then the transpose of the product will be, if AB transpose I have, it is B transpose into A transpose. So these are some of the properties of the transpose of a given matrices. And then for example, if I take a matrix A and matrix B here, then I know multiplication of AB will give me this matrices. Okay, and then I take a transpose of this AB, the whole transpose will give me I can just see that 19, 22, 43, 50. So by changing the rows into the column, I'll get this matrices. This is my AB, the whole transpose. Now this I have to prove it as B transpose into A transpose. For that, let me consider first A transpose. For a given matrix A transpose is 1, 3, 2, 4. For a given matrix B, B transpose is 5, 7, 6, 8. Therefore, B transpose into A transpose will be the resultant matrix of these two multiplication of these two matrices. I'll go along with row into column. So 5 times of 1 plus 7 times of 2, and then 6 times of 3, 5 times of 3 plus 7 times of 4, and then 6 times of 1 plus 8 times of 2, and then 6 times of 3 plus 8 times of 4. Then I'll be getting this matrices, and the final answer is this. If you see, this is our B transpose into A transpose, and this is our AB, the whole transpose. If you observe from 1 and from 2, it is clear that both are same. Hence, AB, the whole transpose is equal to B transpose into A transpose. Alright. Now, let's go to an important method, that is matrix inversion by the Gauss-Jordon method. There are different methods for finding the inverse of a given matrix. So we'll take the Gauss-Jordon method in this case. The Gauss-Jordon method is basically a technique to find the inverse of a given matrix by performing the elementary row operation. So what are the say the steps involved in this Gauss-Jordon method? The first step will be, for a given matrix A, I'll write augmented matrix. What do you mean by augmented matrix? When I write a matrix, given matrix A, together with the identity matrix. So if IA augmented with the identity matrix, then we call this matrix as the augmented matrix. The first step will be the augmented matrix. So we need to form an augmented matrix A, augmented with I, where A is the matrix to be inverted and I is the identity matrix of the same size. For example, you have A matrix as 2 cross 2 matrix. Your identity matrix also should be of 2 cross 2 matrix. If A is a 3 cross 3 matrix, your identity matrix I also should be of 3 cross 3, and so on. Alright. And that is first step. The second step will be, we need to do the row operations. We have to do the row reductions. So performing the elementary row operations on the augmented matrix A, augmented with I, we have to do the row operations in such a way that our matrix A should convert into the identity matrix, and I'll transfer this I into the matrix that will be your A inverse. So I have to perform all the row operations until I get this A has to be converted into the identity matrix. Alright. And then on the right hand side also will be having a resultant matrix that will be your A inverse. Now the important question here is it possible to have the inverse for every matrix by this method or any method? So as we know that for any given matrix, if its determinant is equal to 0, if any matrix whose determinant is equal to 0, we call such matrices as a singular matrix, and then we'll not be having an inverse for those matrices. Then in these cases, what we will get is, after doing a row transformation, any one of the row will become a completely 0. So you will find out the 0 completely 0 row, then your matrix A will not be transferred into the identity matrix. Then we will realize that it is a singular matrix. Hence, we conclude that it has no inverse. Alright. So, those are the things which we're going to see in the Gauss-Jordan method. So, the third step, as I told you, after doing all the row transformation, A can be transformed into I. Then the resulting matrix on the right hand side is your A inverse, and A cannot be transferred into I. Then A is not invertible. That's a simple way we are going to understand it. So let me take now simple example of a given matrix, and we will find out the inverse of the given matrix. Alright, let's see how do we do this matrix inversion by step. Let me take one example and I'll explain you the steps. So if I have a matrix A is equal to say 1, 2, 3, 2, 5, 3 and say 1, 0, 8. So this is the given matrix. As I told you, the first step is I need to write A argument with I. As it is a 3 cross 3 matrix, I have to write a given matrix argument with a 3 cross 3 identity matrix. So let me write the given matrix first. This is my given matrix, and then I will augment this with the identity matrix, which is of order same 1 0 0 0 1 0 0 0 1. Okay, and now this is our first step. Step 1. All right. Now step 2 will be performing the row operations. We will perform the row operations. Now I will tell you, you need to perform the row operation in the same fashion. You can't do it like as we want. So first what we have to do is I have to use R1. This for our better understanding, please know that this is your first row, this is your second row, and this is your third row. And whatever the operations you're doing it on this A matrix, you need to perform the very same operation on this identity matrix as well. Alright. Now let's see. What I do is, first I'm going to make, because to make identity matrix, I need 0 here, I need 0 here. So first let us use R1. These are the steps you need to follow. First use R1. First use the row 1 in order to make row 2, these two elements 0. So let me use that operation. Now this is my R2 and this is my R3. So I'll do this operation. R2 changes to, here you can observe it is 2. So R2 minus, in order to make this 0, I have here 1. So therefore 2 minus 2 times of 1 will give me 0. So therefore I'll multiply with 2 with the row 1. Then I will get this element as 0. And similarly for R3, if you observe, here R3 is already 1. So it is simply 1 minus 1 will be give me 0. Therefore R3 changes to R3 minus R1. This will give me that required zeros. So this will, let us do these operations on this. As I'm not changing anything on the R1, so I'll keep that as it is. Here also I'm not doing any changes, so I'll be keeping my R1 as it is. So I'll be doing the changes on the R2. So it is 2. You can see here 2 minus 2 times of 1. If you want, you can just do these extra calculations side by side. So like say for example R2 is 2 here minus 2 times of R1, that is 1. So 2 minus 2 will be 0. Similarly, here you can see do it for every element here. You have 5 minus 2 times of 2. So 5 minus 4, that is equal to 1. Similarly, you have 3 here. 3 minus, you can do 3, you have R2 as 3. 3 minus 2 times of 3. That will give you 3 minus 6, which is equal to minus 3. And similarly do the operations. 0, it's simple. 0 minus 2, that is negative 2. And 1 minus 0, it is simply 1. With 0, it is again 0. Similarly, here it is simple because R3 minus R1 we have to do. 1 minus 1 is 0. 0 minus 2 will be minus 2. 8 minus 3 will be 5. 0 minus 1 is negative 1. 0 minus 0 will be 0. 1 minus 0 is again 1. So this is our given matrix after doing this particular operation. Now after doing this operation, we need to check that this element, you see I have used R1. Now I'm going to use R2. I'll use R2 and I'll make this element 0. Alright. So now to make this 0, you can observe here I have 1 and here I have negative 2. So therefore R3 changes to R3. So this is negative 2. To make this 0, I'll use this one plus 2 times of R2. 2 times of R2. That's it. Then do this operation. We will get, because as I'm not doing any changes in the R1, I'll keep as it is. Here also I'll keep as it is. R2 also I'm not doing any changes. I'll keep as it is. This also I'll be keeping as it is. In R3 I'm doing the changes. So I'll write here. You can see 0. With this 0 is 0 only. Minus 2 plus 2 will be 0 again. So here you have 5 and here you have plus 2 times of negative 3. 5 minus 6 will be negative 1. And then this is minus 1 here. Here on this side you have minus 1. Minus 1 minus, you can see minus 1 plus 2 times of negative 2. Minus 1 minus 4, that will be again minus 5. Then 0 plus 2, that is 2 here. 1 plus 0, which is again 1. So this is the matrix after doing this operation. Okay, that is done. Now you can observe, we can do here either you can just take a negative element, this negative 1, you can make it as positive 1 and you can continue, or you can do also with the negative 1. So I'll just multiply this row 3. I'll just do this. R3 changes to negative 1 times of R3. Just I want to make this element as positive so that I can use it in the next step. So this will give me, as I'm not doing any changes here, so I'm keeping this as it is, 1 0 0. So this is 0 1 negative 3. This is 0 0 1. So minus 2 1 0. As I'm multiplying row 3 with the negative element, so negative will become positive. Positive will become negative. Alright, this will be now. Okay. And now it is simple. I'll use R3 and I'll make these two elements 0. By using the R3, I'm going to make these two elements 0, that is R1 and R2. So therefore, R1 changes to this 3, here it is 1. So therefore, R1 minus 3 times of R3. Then by using this one, I can make this element 0 because already I have 3 here. So 3 minus 3 will give you 0. For similarly, here you have negative 3. So it is simply R2 changes to R2 plus, because I am using plus because it is negative sign here. So minus 3 you have, plus 1 into, if you multiply with 3, you will get what? You will be getting 0. So 3 times of R3. So let's do this operation now. We will be getting, you can see, as I'm changing the R1. So 1, here it's 0. So no problem. I can write 1 only. And then here it is 2. Since it is 0, so no problem. You can write 2 only. 3 minus 3, which is again 0. Alright. Then you do the same changes here also. So 1, you have 3 times of 15. That is, you can see here. If you want to do the calculations, you can do, as I told you, you can do side by side calculations. So here you have 1 plus, sorry, minus, you can see 3 times of 5. So 1 minus 15, which is equal to negative 14. Alright. Then similarly, you have 0 here. 0, then negative 3 times of negative 2. So that will be 6. Then you have 0 here. And this is negative times of 3 times of negative 1. That is plus 3. Okay. And then do the calculations for R2 also. So you have got 0 here. That is 0. And then this is 1 with 0, which is 1 only. Minus 3 plus 3, which is again 0. So similarly, we can do this calculations. This is minus 2 plus 3 times of 5. So minus 2 you have plus 3 times of 5. Then this will be 15 minus 2, that is equal to 13. Then you have got 1 here. 1 plus 3 times of minus 2, that is 1 minus 6, which is equal to negative 5. Then 0 minus 3, that is minus 3. Okay, then as I'm not doing any changes in the R3, so I'll keep that R3 as it is. So this is our minus 2 minus 1. Okay, yes, now we can see that we have left with only one element in order to make this element as identity matrix. So therefore I'll just simply change, I'll use R2 now in order to make this element as 0. So therefore R1 changes to R1 minus, you can use 2 times of R2. So if I do this, it is simply the given matrix will be, so since here 0, so it is 1 only, 2 minus 2, which is 0, 0 minus 0, which is again 0. As I'm not doing any changes in the R2 or R3, so keep as it is, 0 1 0 and 0 0 1. And similarly on this side, you can see R1 minus 2 times of R2 is there, so it is minus 14 minus 2 times of 13, that is minus 14. You have minus 2 times of 13, that is 26, so that will be minus 40 here. And then you have 6 minus 2 times of minus 5, this is 10 plus 6, that is equal to 16 here. And then you have 3 minus minus of minus 2, it will be 6, so that will be equal to 9 here. All right, so then remaining all no changes, as I'm not doing any changes on the R2 or R3. All right, so you can see this. So this is the observation. After doing all the row operations, you can see all the row operations which we have done starting from here. After doing all the operations, your matrix A now converted in terms of identity matrix. So this is a matrix A which is converted in terms of identity matrix, and whatever the matrix you are seeing on the right hand side, that will be your A inverse. That will be your A inverse. So this is how the trick here will be. First, you will be using for any given row operations, please use R1 in order to make the first two. For example, if you take this A, B, C, D, E, E, F, say G, H, I, if this matrix you are taking, then use R1, then make these two elements 0. Then use R2 to make this element 0. Then if any, for example, you may get fraction here, or you may get a negative element here, as in this case, then try to remove that and use R3 and then make this and this element 0. All right, then reverse, use R2 element in order to make this R1 element 0. So use R2 element in order to make this element 0. Okay, and after doing anything, still if you get any fractions or anything, then you can just take it down and make sure that you're converting the given matrix in terms of identity matrix, and whatever the right hand side matrix you'll be getting, that will be your inverse matrix. So maybe in the next example I'll show you if after doing the row transformation you may get the all zeros in one of the row, and then it is not invertible. That discussion we'll be doing in the next video. Okay, then I think with this we conclude in today's discussion, guys. Please take care. See you all in the next video. Till then, take care.